Cool. Hi everyone, my name's Azrael, and today I'll be talking to you about Peace, my side project, and it's an automation framework. So as with every side project, there is an origin story. And for Peace, the origin story is a team of us at work were given this process to deploy some servers, but we wanted to turn it from a manual process into an automated process. So obviously, the answer was that, right? Like any engineer would think, you take the manual steps, turn it automatic. And so what we wanted was to have a one-click deploy where we click, wait, and then done. So the process should be as hands-off as possible. And we aimed for end-to-end automation, repeatable correctness, and we want it to be performant. And if you use these metrics as your success measure, then it was undeniable. We took our deployment time down from 2 weeks to 30 minutes, right? So by all engineering metrics, it was good. But our users, they did not like our tool, because when we turned their work from a manual deployment process to a automatic deployment process, what we really did was we did this. So we took the process where we do step 1, 2, 3, 4 at their own pace. They can learn what they're doing as they go. To let's define the parameters for all of the steps, feed it into a process which they could not understand because they can't really see anything beyond something's going, like a spinning process. And then at the end of that 30-minute process, check if it worked. And because they didn't really understand all the steps or all the parameters, often they would have to restart at the beginning, where you have to tweak your parameter, wait another 30 minutes, and see it fail again, right? So if you've ever worked with a new automation process, it's always frustrating when you have to go through this cycle. And we knew that our users did not understand what they were doing, but it was for sure our fault, because we knew what those parameters meant, but they didn't. So really, we just failed to communicate what each thing is and what each thing is supposed to do. So I revisited this after I learned and got some human eyes. So we still want to put in the engineering values or the automation value, which is the first 3 points. But what we took away by switching from automatic to manual deployment, manual to automatic deployment, is we took away understandability, we took away control. And when you take away those two benefits of manual automation, manual deployment, you also take away morale. So we need to put that back in. So that's what Peace is trying to do. What we want to do is we want to get the benefits of automated deployment as well as retain the benefits of manual execution. So the Peace framework, what is it? Well, normally when we code some automation script or automation tool, we put in 1 unit of work and we get out 1 unit of automation value. What I really wanted for this framework is we still want to put in only 1 unit of work, integrate it with Peace, and we get 10 units of value. Because usually, even though high value is really desired, what we really have as a bartering chip is we only have capacity for 1 or 2 units of work. We cannot increase, say, work to about 4 units and still get 10 units of value. Even though that's a disproportional return, we only can barter on how much capacity we have, not the value that we gain. So it's important that if I could make this framework have as little integration effort as possible, then at least there would be some hope of getting that 10 units of value. Now, just before actually, yes, I'll show you the next slide, and then I'll show you some code. So I'm going to show you a tool built using the piece framework called Envman, short for Environment Manager. And what it is we take your automation process, regular code, we write it in the form that piece can understand, and you get your tool compiled at the end. And Envman, what it does is it downloads a file from GitHub. It creates some resources in Amazon, and then it uploads that file to Amazon. The file is a web application. So there's a missing step like launch a server to run the web app, but that would make it useful, and that would also cost money. So I've stopped there. Cool. So the code that you should be aware of for this tool is this. Oh, it's not good on this screen size. Try this. All right. So all I want you to look at this bit. So these are steps in our process that Envman will run, dependencies between the steps, as well as parameters to those steps. I'm going to just collapse some of this. Okay, so parameters to the steps. So if we look at this snippet here, lines 87 to 93, file download parameters are, I want to download a file from this URL, and I'm going to write it to this path on disk. So in terms of conceptual difficulty, should be quite simple to understand, right? There's no imperative logic. If you were writing any YAML code for like, I want to download a file, it's still declarative. We have our parameters to the thing we want to do, and so on and so forth for all of the other steps in the process. Okay, so if we look at line count, 100 and something lines, 200, close to 200 lines, that's the amount of effort I want people to have to spend in order to get the tool that you are about to see. If you need to spend a lot more effort just to integrate your automation process into the piece framework, then we've already lost. So I'll cover what that means at the end. Cool. So the first thing we took away when we created our automation tool in the first project was understandability. So let's put that back in to an automation tool. Cool. So there are two ways we tend to write automation. The first way is we produce so little information that we don't really know what's going on. So that looks like this, right? So nothing's produced. We can't tell what's going on. The other way we write automation is we produce so much information that we still can't tell what's going on because there's so much information, I read none of it. So essentially, it just turns our minds off, right? So ideally, we produce some amount of information in between the two. So we'll run this again with the optimal amount of information. Cool. So just from one screen of data or output, and because all of you have fresh eyes, how many steps are there in this process? Of course, 6. And did it work? Right? Green means good, right? You don't even have to ask. It's like trivial. It's insulting to ask. But compare that to the huge amount of information. Someone who hasn't seen the command line before, they're going to be like, ah. But you see this? It's kind of digestible. And if we look at the output below, how many, well, where do all of the resources that were created live? There's a link to each of the Amazon resources, plus there's the path to the file on disk. So if you wanted to find the thing, it's there, it's shown to you. You don't have to ask. And if we clean up, familiar interface, do we know that all of the resources we've created have been cleaned up? It's quite clear, right? Because the thing with automation is if you create stuff in the cloud and you forget, it's just leaking money. And so we want to be sure that everything we create, we clean up. There's no, I think I did that, right? You want certainty, not confidence. So this is nice when things work. So you can understand things when they work. Can we understand things when they don't work? Whoops, deploy. All right, so what I'm going to do here is while deployment's happening, I'm going to cut my connection, but I'll cut it ish for just our demo application. So just to be sure, here we go. So we're going to throttle the connection speed for Nfman to 40 kilobytes or bits. I'm not sure. So here we go. And at some point, I will do this. All right. So this is real. It's talking to the internet. So you can see that our connection speed has dropped. And at some point, we should have an error. And I want you to say whether you can understand where the error lies. All right, let's scroll a little bit. All right, so which step failed? Obviously, step 6, right? The red thing. And anyone who has never seen this before can tell you. And for all of the steps, can we tell easily which resources were created, which resources were not created? Completely obvious. And this is like when you have a script fail, you normally don't know, but this thing, it tells you, it knows, it tells you, right? So that's like really music to like automation engineers' eyes. And for the error, what went wrong? Well, we know it's the S3 object, and the reason failed to upload the S3 object, why it timed out. And another thing here, it tells you how to recover. So make sure you're connected to the internet and try again, right? So pretty much you don't just take your temporary, you don't just take your timeout error and then just splash it to the user. You actually take time to convert it from technical error to human English, right? Not technical English. If we fix our connection, which is this one, I'm going to deploy again. And with the dot slash, all right, so what I'm going to do here is I'm not going to think about will my script be idempotent because it already is. So it knows the first 5 steps were done. I didn't have to think I'm going to push the button as many times as I want. It will only do the work that is necessary. So so step 6 was it failed previously, and step 6 now works. Cool. Clean. All right. So with information, in order to have understandability, the Goldilocks principle applies. Too much information is overwhelming, too little is not useful, and there's a level that's just right for each individual. So the special thing here is the more understanding you have, the more capacity you have for information. So if we really wanted to show more information to the user when they're ready for it, then we can. We just don't do that by default. Because most people, even if you understand a lot, you just need to know the big picture. You want to see things at a glance. We do keep all of the inner information inside inside piece. Let me just do this. so you can see it. So we can see for every step what the state is. So this information is available. We just don't show it to the user until they need it. Cool. Now, the second thing we took away from our users when we switched from manual to automatic is we took away control. So we also need to put that back in. Now, with automation, normally you get one button. It's like start, and that's it, right? Like start the process or start the clean. But importantly, it's easy to press start, but understanding what the automation would do before we press start, that's hard. So what we really want to know before we press start is the current state where we are, the goal state where we want to be, or where the automation would bring us to, and the difference between the current and goal. Because if we start somewhere in the middle and our goal state is over there, then the difference is just a little bit, right? We don't have to run everything. And there's one more important thing about control, which is we press start, but then we change our minds. So with manual deployment, when we change our minds, we might go, I'm here. Let's stop where we are. Let's go fix the thing that was incorrect. But with automation, what we really want to do is when we change our minds, we want to stop it as soon as possible, but safely. So if we were to hit Control-C on the script, you know that it's going to interrupt the process at some weird place, and you don't really know what's happening behind the scenes, right? Whereas if we can tell the automation, hey, I'm going to interrupt you, but you decide when's a safe place to stop. And the automation will stop at that safe place, right? That'll be the ideal. So the safest place we can stop is between any two steps, because when you finish one step, atomically manage one resource before you start anything else, that's a safe place to stop, right? So that's what we want to do. So one more point is when you stop, you took so much effort to get to where you are, don't throw away what you've done. So if you ever use CloudFormation, you know that you CloudFormation deploy and you do CloudFormation update. If it fails during that update, it's going to think, oh no, I need to revert to my last known good state. But you took so much time to get here, and I just want to tweak one thing, right? Don't throw away the work you've done. So the overall process, we don't really want it to go back to the beginning. We want to get to the end. Just because you stop in the middle doesn't mean we need to go back to our last known pristine state, right? So it's atomic per item, but we don't have to be atomic for the overall process. Cool. So let's see this control in action. Cool. So first thing, if we were to start a project, we would initialize it. So I'm going to show you how parameters get into this process or this tool. So we call envman init and pass in some parameters. This can of course come from files, but then in this case, I'm just feeding it in through a command. Now, before we press the deploy button, we want to know where we are. So just like Git has Git status, envman has envman status. And because we have a clean slate, everything doesn't exist. Where will our automation process bring us to? We have envman goal. So this will tell us that the first file, webapp011, should be 6 megs. Probably could work on the interface for that. And all of the resources in Amazon, they should exist at the end of the deployment. The unknown here is one of two things. There's a bug, and the other thing is we cannot tell the size of the object that should be uploaded before we've downloaded it. So step one downloads a file, and we cannot actually tell at this point in time, because my file for step 6 doesn't exist, we don't know how to calculate the target state for that step. If we want to do some magic, like backtrack into your dependencies and figure out what's going to happen from that, that's like beyond me at this point. All right, so we know our current and target states. The other part is what's the difference between the two. Okay, so for the difference between nothing and something, the difference is something. And I'm going to deploy, but before I let the process finish, I'm going to interrupt the process. So you can see what interruption looks like. Maybe here. All right. So at this point, can you clearly see which steps were completed and which steps were not? Right. So there's no guesswork. And if you need to access those resources which were created, you've got links to them. If you want to look at what doesn't exist, well, it doesn't exist. And at this point, what I want to do, let's say, is I want to change the parameters that I fed to my automation. Right, so I'm going to init again, but instead of 011 for my web app, I'll use 012. Now, at this point, step 1 has changed its parameters. Everything else, probably not, right? So if I run status, you'd see that the web app 012 doesn't exist on disk. And for steps 2, 3, and 5, which were previously completed, they still exist. And so if I were to run npman diff, we can tell that steps 1, 4, and 6 will have something done for them. But for steps 2, 3, and 5, where none of the parameters change, it doesn't have to, the automation doesn't have to do anything. It's like the work's done, so don't touch it, right? So if I were to run deploy, exactly as I understood it, it happened. So no guesswork. And if we were to decide, all right, let's clean up, and we change our mind in the middle of cleanup, right, and interrupt here, we've gone from a completely deployed state to a halfway state. And instead of needing to clean up completely, we can go from this halfway state to the fully deployed state again. So automation is no longer just one direction, like go from 0 to 100 or 100 to 0. We can go from, well, 0 to 5, 5 to 10, and then 10 back to 5, and back to, well, back to 10 if you want, right? So if we were to deploy from this weird state, we'll see that steps 1, 4, 5, and 6 will have work done for them, and the rest of them will just, well, 2 and 3 will do nothing because we didn't clean them up previously. So here, there's complete control over the process. And there's a fun concept which I haven't done yet, which is I want to select a subset of my process and run that. That would be really cool because if you're testing, for example, installation of your application or just a service launching in your big cloud environment, let's say you deploy the first 5 steps to deploy the cloud infrastructure minus the servers, then you iterate over step 6, which would be just launch the server, install your base application, and clean that step 6 up. That'd be a really fast process instead of iterating over the whole deployment process, right? Faster feedback. So that's an idea that's not yet coded, but completely possible. And let's clean up. because it does cost a little bit of money to keep that object in the cloud. All right. So at this point, do we have any questions or comments about the what you've seen so far? Nope. Clear. Oh yes, Yan. Yes, but we need to be clever about that. Yeah. So do we find whether mm. Yeah, so is it a problem to maintain the thing that talks to the AWS APIs? At this point, the demo is all the code you see, and I'm using the AWS REST SDK or SDK. Yeah, so far it's been quite stable. I've upgraded minor versions like over months and almost no maintenance required. Yeah. So yeah. Yeah, and I think the AWS REST crates, at least the APIs I'm calling are stable. Yeah, so I haven't dabbled with the newer services, and I'm just talking to IAM and EC2, so nothing major there. Yeah, cool. I've done that. All right, so we have put back some understandability and we've put back some control. But if we think about understandability, not everyone who uses automation tools works with the command line. And certainly our users from the first project, they were not software developers. They could be grads, they could be people like clinicians from other industries, right? And getting them to touch the command line, that's like a big bad assumption that we made. So can we do something that actually caters for non-command line usage? And so I thought, well, when we explain automation processes, normally we might talk about the steps, but we also talk about the deployed environment and we draw boxes on the whiteboard, right? And when we talk about communication between those hosts, we tend to have a lot of lines just overlap and it gets messy. So why not generate a diagram for the deployed environment? And we can use that to explain what's going on. So here's what I did for that. Here's a web interface. Currently runs locally. Whoa, let's shrink it down. All right, so I guess you can see blobs. You don't need to read the text. I'll read the text for you. All right, so the diagram on your left, yes, is the process diagram. And so the process diagram shows you the steps in your it's a progress diagram. The progress diagram shows you the steps in your process. So over here, we've got 6 steps and we've got the order between them. Yeah, there's a missing like use the permissions we've created plus the web app and launch it. Yeah, that's a missing step. But if we look at the diagram on the right, we can zoom in. So kind of duplicate, but we've got these green boxes on the right, where we show you the steps in your process. And if you click on each of them, this one is the web app file download. And you will see that the box representing localhost and GitHub, or rather the file paths, we've got arrows flowing between them, showing the request made to GitHub and the file written to disk. If we go to IAM policy, localhost is talking to IAM and creating the policy. Same for role and instance profile. Next, we create the S3 bucket. And finally, we upload the S3 object. And you can see that it's using the same nodes or the same boxes and highlighting them for this file, which was downloaded from GitHub, is now being uploaded to S3. And this is completely generated from the code that you saw earlier, right? You spend zero effort on diagramming, and you get something like this. And what's really nice about this is when you're explaining a process to someone and they're like, go back to that previous step, right? Which one? You can click on it and you can tell them, what authentication is happening here? Or we just use basic auth, or it's public, or whatever it is. You don't have to go to your whiteboard and redraw the lines or erase the previous lines and try to make sure the diagram just works. It's all there for you. And I know this is great. This is great, right? I'm just happy if I can have something like this at work. But I also like this other one. So what you saw earlier was the example environment, what the environment would be like when you deploy it. But we can also show you the actual environment, what it is right now. And right now you see no boxes, or they are highly transparent. That means all of those files, all of those resources, they don't exist in Amazon. When we click deploy, these are real-time generated arrows. So when you see the arrow happening, that's the request happening in the background. And when it's complete, all of the boxes have become opaque, meaning they exist. So you just look at your diagram. Does my IAM profile exist? Yes, it does, right? You don't even have to guess. And if you're a command line user, you run your status command and you see that there. Now, we can clean up, and we can also do the same thing we did with the errors earlier. So while we're running the process, we'll slow down the internet. Okay, so let's try that. Somewhere here. All right. It'll take a little bit of time to, did I actually do the right one? Hopefully I did. All right, so if I did it right, an error will appear, and you can tell from the diagram which thing the thing failed on, right? Because if you get a stack trace, or if you get logs, you have to look at the logs. I don't want to have to look. I want someone to tell me, hey, where's the error? It's with this file and that object. Don't have to think. So yes, we can surface the error message on the web page. Right now, it just writes to the console, but just haven't coded that part yet. But yeah, if we can surface everything you need on the web page, then you don't need your non-software users to use the command line. You just create something that they've got buttons they can press, they can understand, right? So they've got control. So that's the point of having this kind of interface. Cool. So let's fix this. I think I did that right. Oop. And clean up. All right. Okay, so back here. So a lot of effort has been put into aesthetics, because for morale, well, for the state of your environment, if you've ever worked as, if you've ever been on call and you had to go find an error in your environment, we show you the state of every item on one line, because at 2 a.m., and if you have to go find your database, you know you've got a database and the issue is probably there. 5 clicks to get to my database in the web console is 5 clicks too many. So I just want to think, I want to go to this place, take me there, right? So don't make me click through the web console. I just want to get to that thing. Yeah. And for progress, instead of showing too much information, we just distill it down to something digestible. I look at my progress bar. I know it's like 20% done. Don't have to spy, oh, I know this line comes at like 80% of my 80% through my deployment process. You don't have to do that. Just a box is good enough, right? Similar for web, we do have something like this. Probably can be tuned a bit better. And for errors, instead of panicking, which is like printing a stack trace, right? We take your error, we feed it to Meetup, so we make it, refine it, and we make it beautiful, because if you can understand it, then it's less overwhelming. And we always show you what went wrong, always show you why it went wrong, and always show you how to recover as much as possible. Because when you help someone recover from a bad situation, you recover their morale. And that's so important for people who are like, they're already scared using a tool. You better help them along when something goes wrong. Okay, so for a lot of this aesthetic work, right, we've turned this opaque process, like this automation process which you cannot see into, we've made it clear. We show you the steps. So when you can understand it, when you can control it, then maybe it's not so scary. Maybe you have a bit more morale to do your work, right? So that's the demo we've got so far. How does all of this work? Magic. So show you a bit of the Rust architecture or the piece architecture. So we've got the piece framework, which is mainly split into two parts: the item definition, and this is where we have the item traits. So traits in Rust are like interfaces in other languages. It defines the shape of your logic, defines the shape of your data. And we take these shapes, and we've got common functionality. So we give you command execution, which is like, what's common functionality about that? We'll see that shortly. We give you a user interface, command line or web, and we put in the good stuff like idempotence, interruptibility, like cleanup. All of that's handled for you. And implementers, so these are the two main bits of work that you might have to do. So the item crate, this is where someone has to implement the item traits. So like a file download or launching a server, a file download is a file download. It's not really proprietary information, right? So you're connecting somewhere, downloading it to disk. That's not a secret. It might be, but generally not. But what may be a secret for downloading a file is the values you pass into that logic. So the URL to download from, maybe the credentials to use to access the location, those are secrets, and those will live in the tool. So the tool will combine multiple item crates, feed them into piece, and then that's the fully built tool at the end. And we'll go a little bit deeper into each of these. Okay, so the first one, item. So instead of thinking about steps in the process, we think about items in a flow. So flow is a fancy name for process, but every item, instead of just defining the logic to do the work for that step in the process, which is the apply function, we also require some logic to read the current state, which is like, tell me what the file is on disk. Maybe it doesn't exist, or maybe it exists with this content. The goal state is, what should it be? So for a file download, it would be the goal state of the file on disk is whatever the server has, which may be a different version of your file, right? Diff is, tell me the difference between two states. So between current and goal, what's the difference? Maybe it's nothing and something, or maybe it's version 1 and version 2. So diff will tell you a description of what that difference is. Clean is tell me what it looks like when the file doesn't exist, trivial function. And interactions, this is where you do need to tell piece which hosts and what kind of interaction is happening between those hosts. Like, is it a push or is it a pull of data? Or is it within a host, I'm just munging some data on disk? So that's all encoded into interactions. But hopefully your item is defined for you, then you don't have to define any of this anymore. But because piece is relatively new, you probably have to. Okay, so an item is a collection of functions. A flow is a collection of items, as well as the dependencies between them. So here we have, we're downloading a file and we create an S3 bucket, and those two must happen before we upload the file to the bucket. And commands is where this is common functionality from piece. We will take your flow plus some parameters, and we will run certain functions within each item. So the discover command will run the current state, or discover the current state and discover the goal state for each item. The diff command will calculate the diff between those two states, and we present that to the user. The ensure command will turn the current state into the goal state through the apply logic, and the clean command will turn the current state into the clean state with the apply command logic as well. And the biggest magic in this diagram is like that arrow, because we sometimes need to feed parameters from like the output of step 1 into the input of step 2 in the framework without knowing what types they are. So to do that in Rust, that's black magic. And I don't want to do it again. All right, so finally, we have our tool. So we've got the parts you've seen earlier. So we've got our items collected into a flow. We have our parameters to those items. So, some of these parameters may not be values directly. They may be take the output of step 1 and feed it into that one. So that's what that parameter might be. You take your interface, so command line or web, and you pass all of those to the respective command to run. And you surface these commands to the user under maybe different names. So the deploy command you saw earlier, behind the scenes, it's ensure. And this is the part where if you need to have any proprietary information, you can read it from wherever you need to. So you have complete control over where you store secrets as well. Okay, so status of the project. So is piece ready to be used? Short answer, no, but elaboration here. So for development workflows or short-lived environments, like what you saw earlier, you run the deployment and you clean up within the same version of your tool. It works. It's correct. It's tested. But if you have a tool which evolves, like you add more steps into the process, subtract some steps, it does not work. So do not use it for those. So clearly, no production workflows, no stable environments. In terms of code, the item and data traits are quite stable. I add to them. I haven't changed the signatures very much. But in terms of calling the common functionality, those do move around quite a bit. So probably don't use this if you really want something stable. Some links. So piece.mk for the project website, piece.mk/book for the slides, and GitHub for the code, MIT license, Apache 2.0. So do what you wish with it. Now, I'd like to wrap up with this quote: to engineer with empathy, whether it's verbal, visual or vocal. Find your voice. Connect with people and communicate with clarity. Thank you for listening and happy to take questions. Max. Do I use power? Oh, no, I don't. I don't. Ah. Yeah, maybe I should. No, I don't. I use leptos, which backs onto exum, so think tower is somewhere in that space. I've never explored it. Yeah. Colin? Yeah, so if the API allows it, if we're talking to an API, then there's the discovery step, which you can run manually. We can run that, or you can, at the start of every deployment, I run that code because if someone else has changed the environment before you've touched it, then it's like a git push. You don't want to push over someone else's push, right? Unless you want to. Yeah. Mm. Uh, that's like P's version 2. I don't know yet. Yeah. Yeah. We'll go with Nick and then. Oh, the black magic between the items. Yeah. So I'll show you maybe the diagram and then the code for it. So if you're passing the values between two steps, right? Yeah, so here is what I do. I kept this code here on purpose. So every parameter type has its fields, and you can call dot with manage policy arn, and you pass in the value directly, or for your parameter types, I generate these two functions. We'll just look at from map right now. So with parameter name from map, we'll take in the closure, and magically looking at your closure parameters, we will know that, all right, somewhere in our chunk of memory, there's going to be an IAM policy state. So read that and then feed that into this function, calculate what the ARN should be from that, which is just reading a field from it, return that. And because it's Rust code, you can do any transformations you want. But yeah, the real black magic was reading the function parameter types and then finding that in memory and then feeding it into this. Yeah, yeah, yeah. And there's another layer of complexity, which is within one execution, if you're discovering the current state and you're discovering the goal state, the current state of this IAM role params should be derived from the current state of the previous step, the previous item. Whereas the goal state of the IAM role params should be derived from the goal state derived from the goal version of the IAM policy state. So we keep multiple copies of stuff in memory, and we just need to make sure we read the right one. So it's type reflection, but with another wrapper around it. Yeah. Runtime. So we use type ID. So it's type ID map. Yeah. And Yan. Yeah. Yeah. Mm. Correct. Yeah. So that's I actually did this for my previous workplace. Yeah, either previous workplace or previous workplace, where I had a few artifacts to be generated, and I had bash scripts backing the items. And so yeah, there's a bash item execution. There's a shell item executor which just has like one-liners, and that was my build system. Yeah. Yeah, yeah. So at that point there was no diagram generation, so all the visuals that came in last year. So does it work if you've got thousands of stuff going on? So the upper limits that I've discovered may exist in dot. So right now I'm using dot compiled to WASM on the web page, and dot is known to have some crashes at some high limit. And one of the things I wanted to do is replace that with layout RS, which is like a dot rewrite in Rust, but fairly small portion of dot has been rewritten. Just like plain labels, no HTML like labels, and it's a bit different in their layouts, but close enough. Yeah. Hmm. Hmm. Those are done with a procedural macro. So I think I can just go to this thing. Yeah, so derive params. That's something that I've written, and from this derive, it looks at your fields, and it generates all of the other with blah 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 methods. Yeah, they can't. I mean, I can't do it without that. Oh, you mean if the type exists? Correct. So if it's someone else's type, only that library can derive params, or you have to write a wrapper type and then do a from. Oh yeah, like DSL. Yeah. Um. Yeah. Uh, no, I haven't considered using that. Yeah. Yeah. Cool. Any more? Oh yeah. Undo. Oh, so the apply logic takes in two states, and a state may be I don't exist, or I exist with this version, and another state may be I exist with this other version, or I don't exist. So the cleanup will be I take in the current state as whatever it is, and the target state of I don't exist. So the apply logic needs to handle turning that into nothing. So essentially, we have a state machine for each item. Mm. Yeah, it's not the cost to actually integrate with piece is still maybe so the 6 units of work to get your 10 units of value, but I'm working on reducing that 6 down to hopefully a 2 or a 3, right? Because at least 2 or 3 you can justify that for the amount of value you get. Mm. So if that's us, then thank you for listening and